Hello everyone and welcome to another at Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 6 Trigonometric Functions, Long Question, Example 5. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question. Prove that 3 secant square x minus cos square x minus 2 equals to 3 tangent square x plus sine square x. So this is the question part A. Continue to read the question part B. It is given that sine theta is equals to 5 over 13 and tangent beta is equals to negative 4 over 3 such that both theta and beta are in the same quadrant. Without using a calculator, find the value of cos in a bracket theta minus beta. Okay, so this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. For the question part A, it is involving the proving where left hand side should be equals to right hand side. Okay, to solve this question, you can actually use any one of the side for the proving, but to solve this question, I'm going to use the left hand side. Okay, so let me write down this equation into my working here. So given that 3 secant square x minus cos square x minus 2. Okay, by the end of my working, I should get 3 tangent square x plus sine square x. Okay, so the first step what we need to do is we need to have the tangent square x in our working here. So how is it possible? Okay, so try to recall the basic trigonometric identities, guys, where tangent square x plus 1 is equals to secant square x. So as you can see here, you have secant square x here. So this secant square x you can substitute equals to tangent square x plus 1. Okay, so that will be our next step of working. So from here, 3 in a bracket tangent square x plus 1 close bracket minus with cos square x minus 2. Okay, so from here these 3 we're going to times in the bracket. So from here you get 3 tangent square x plus 3 minus cos square x minus 2. Okay, so from here these 3 will be minus with 2. So from here you will left with 3 tangent square x minus cos square x plus 1. Okay, so that will be your step number 1 by changing the secant into tangent square x plus 1. So try to compare with the right hand side equation again. Okay, you have tangent square x and sine square x. So this sine square x you must relate it to this equation. So how is it possible for us to relate to this equation? So try to recall again the basic trigonometric identities where sine square x plus cos square x is equals to 1. So in order to find this cos square x, so it will be equals to 1 minus sine square x. Okay, so from here let us continue our working. So it will be equals to 3 tangent square x minus, okay, and then in a bracket 1 minus sine square x close bracket, and then plus with 1. Okay, so this negative you times inside the bracket. So from here you get 3 tangent square x minus 1 plus sine square x plus 1. Okay, so this negative 1 and positive 1 will cancel out. as it will become 0. So you only left with 3 tangent square x plus sine square x. So as you can see here, we have already proved that the left hand side is equals to right hand side. Okay, so from here, so this will be your final answer, 3 tangent square x plus sine square x. Okay, so let me underline the solution for the question part A. So let us proceed our discussion for the question part B now. Let us start to solve the question part B. Okay, if you take a look at the information over here, it is given that sine theta is equals to 5/13 and tangent beta is equals to negative 4/3. And they also mentioned that the angle theta and beta are in the same quadrant. Okay, so one value gives us positive and another value gives us negative. So the first step, what you need to do is you need to identify in which quadrant does the sine value gives positive and at the same time the tangent value gives us negative. Okay, so in this case it will be in second quadrant because your sine can only be positive in first and second quadrant. Okay, so in second quadrant you can know that your sine theta give us a positive 5/13 and tangent beta gave us a negative 4/3 value. Okay, so that will be your first step. So now we know that it is lying on the second quadrant. So the next step, what you need to do is you need to sketch a diagram regarding theta and beta. Okay, so from here you will be forming two triangles, or to be more precise, it will be two right angle triangle. Okay, by the way, I've already completed the sketch for you. So let me show you the full diagram now. Okay, so this is the complete sketch. Like I've mentioned, there are two right angle triangles over here. So let me begin with the first right angle triangle. Okay, since in the diagram it mentioned that sine theta is equals to 5/13, so this is the first information. So let us begin with this itself. Okay, so this is the triangle where it involves sine theta is equals to 5/13. Okay, sine, the formula to find the sine is opposite over hypotenuse. Okay, so in this case you should know that your opposite is 5 and your hypotenuse is 13. Okay, so how to find the length of the base? So you need to use the Pythagoras theorem. Okay, so in this case it will be 13 square minus with 5 square and then you square root it. So in this case you get your answer is 12. But be careful, this 12 is just the length. Okay, you should know that since your values lies in the second quadrant, so you should start with negative 12 up to 0. Okay, so you should know that your x axis give us the negative value over here. Okay, so this is the information that you need to know about. Okay, so this is for the first triangle. Okay, let us proceed to the second triangle where tangent beta gives us the value of negative 4/3. Okay, so let me scroll this down. So the formula to find the tangent is opposite over adjacent. Okay, so the opposite, as you can see here, is 4. Okay, the height of the right angle triangle is 4. However, take a look at the base. Okay, the base gives us a negative 3. So that's how you can form the tangent beta is equals to negative 4/3, guys. Even though your vertical length is positive, but you see your horizontal distance is negative. Why it is negative? Because your x-axis is in the negative region. Okay, so I hope you understand, guys, the concept for this. Okay, so from here you need to find the length of the hypotenuse. So how to find the length of hypotenuse is very simple. Okay, so your distance is negative 3, right, and your vertical distance is 4. So what you do, 3 square you plus with 4 square and then you square root it. So when you square root it, you should get your length of hypotenuse is equals to 5. Basically you need to use the Pythagoras theorem here as well. Then you can ask me, so why I need to find all the relative length? Okay, there is a reason, guys, because in our upcoming working we're going to need all the length in order to find the respective trigonometric component. Okay, so from here, since we have already formed these two triangles, let us proceed to our next step, where we need to form the value of cos in a bracket theta minus beta over here. Okay, so this cos theta minus beta we can form using the compound angle formula, guys. Okay, if you don't know what is exactly the compound angle formula, so I'm going to show it to you now, so you can use that as your reference. Okay, so let me write the compound angle formula in related to this question, guys. So from here, cos in a bracket theta minus beta is equals to cos theta cos beta plus with sin theta sin beta. Okay, so this is the expression that we have formed based on the compound angle formula and from this diagram. Okay, so from here, this cos theta and cos beta, sin theta and sin beta, we can obtain from the triangle that we have formed, guys, through our sketch here. Okay, so from here, let us begin our working. So from here, let us begin with the cos theta. Okay, this cos theta, you take a look at the green triangle over here. Okay, so the formula to find the cos theta is equals to adjacent over hypotenuse. Okay, so from here, the formula will be adjacent over hypotenuse, but you need to be careful. You need to choose the negative value of x, since your x-axis is lie on the negative region, so it will be negative 12. So your adjacent will be negative 12 and your hypotenuse will be positive 13. So your cos theta will be equals to negative 12 over 13. Okay, so this is the value of cos theta. Okay, continue to find for the cos beta now. Okay, for the cos beta, you take a look at this red triangle. Okay, so I use two color triangle in order for you to differentiate easier. Okay, so from here, let us take a look at the cos beta. Okay, so similar calculation for the cos theta. So the cos beta is adjacent over hypotenuse. Okay, so in this case, your adjacent length is negative 3. Okay, and then your hypotenuse is positive 5. So it will be negative 3 over 5. Okay, so from here, let us continue. Okay, and then you plus with sin theta. Okay, back to the green triangle over here. Okay, sin theta is already given in the question, which is 5 over 13. So you just copy down the 5 over 13. However, if you want to know how to find the sin theta, is actually equals to opposite over hypotenuse. Okay, so your opposite is 5 and your hypotenuse is 13. So it will be equals to 5 over 13. So as you can see here, this is the reason why your sin value is positive in second quadrant. Okay, so from here, let us proceed to the sin beta now. So for the sin beta, take a look at this red triangle again. So it will be equals to opposite over hypotenuse. In this case will be 4 over 5. Okay, you times with 4 over 5. Okay, so from here, this 5 you simplify, you get 1. So this 5 you simplify, you get 1. So from here, let us continue our working. So it will be equals to, so negative 12 times with negative 3, so it will be 36. Okay, and then 13 times with 5 will be 65. Okay, and then you plus with 4 over 13. Okay, so from here, so in order to add these two fractions together, this 13 will have to times with 5 and the 4 will have to times with 5. Okay, so let me copy paste this expression. So from here, your cos theta minus beta will be equals to 36 over 65 plus with 20 over 65. Okay, so let me copy paste this. So you plus these two fractions together. So from here you should get your final answer. Cos theta minus beta is equals to 56 over 65. So this is your final answer. So let me underline the solution for the question part B. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.